All right, welcome to another video. We're going to be verifying option C. So let's jump over to PE1 and make sure that looks the same. PE1 looks good. Let's jump over to, let's look at the routes being advertised from PE1. So here's the issue. We're not advertising anything out from P1. So let's take a look at the Bgp summary. So here's a bigger issue. We've got a active to PE2. So we're going to need to troubleshoot and make that go into established. So let's start by doing a trace route over to that address. We can see the trace route stops at 2.6. So we can stop the trace route early. And then I'll do a refresh on that. And then we noticed in the earlier video, it's going to cycle from connect to active. So just because it's in connect now doesn't mean that it's necessarily going to be able to connect. As long as I can't trace route to that address or ping that address, we know that there's no chance that it can connect because it rides on top of TCP. So yeah, that can just stay in connect, kind of hoping that I'll jump over to active soon, but really there's no reason it can't be in connect. So let's move on and try to take a look at where it stopped with that trace route. So it stopped at this address here, and then it wasn't able to move on. So let's take a look at the configuration on ASBR1 and make sure it matches the documentation. And sure enough, it looks like it matches as far as the interfaces are concerned. Let's check the protocols. All right, let's check BGP. So, oh, it's got a capital T and a hyphen. So, but even with that specified, it looks like it is missing that configuration. Oh, actually, it looks like it does have that. So I'm not sure what the difference is between, oh, so that's got an underscore. So it looks like I did enter it in different from how it appears in the documentation. I can go ahead and clean that up and make it match. Really, it's not a heavy lift to do that. So protocols, BGP, and then show pipe display set relative. So now I can do edit group, then with the underscore, show pipe display set relative, and I can delete everything under here. Now I can go up, edit group with a hyphen, and I can just grab everything is here and paste it in there. And that's kind of the power of that display set relative command. You can see just how useful that command can be. So let's check the group to ASBR2. And here you can see another issue with the documentation. We've got BGP showing up. Of course, there's no protocol group. It would be edit protocols BGP group, but you can see that's missing here from the documentation. So another thing that's not quite worth a downvote, but as they kind of pile up and you've got mistake after mistake, there's some point where that might just be worth a downvote itself. But for now, I'll just keep moving on. So everything looks good to go here. Keep verifying. Everything looks good there. Let's take a look at the last configuration. All right, so there's only one difference between the way I had configured it and the way it was configured in the documentation. That was just this hyphen for the underscore, so it's really not going to make a difference, but just to make it match, I'll go ahead and commit that. And you can add this and quit keyword, and that'll take you out of configuration mode afterward. So let's verify ASBR2. Oh, and I think we found the issue. And this makes a lot of sense because we could see that if we did that trace route, you can see that it's got two statements here. So you might think that means for entering and for leaving. But let's go ahead on ASBR1 and let's see if that might be the case. So ASBR1, let's see what 1.4. So 1.4 isn't going to be on ASBR1, but right, because ASBR1 has this 2.6. So this is going to be the PE. So let's look at the PE. Sorry, the P router, the transit router here. And let's get a better sense for how those labels are assigned. So we're looking for this interface here, 1.4. And that's going to be GE000. Let's take a look at the show run. So that's going to be the one pointing to the PE1. We're also going to have GE001 pointing to ASBR1. So let's take a look at the labels that we see here in the trace route. So show MPLS label. Or how about show MPLS LSP maybe? It's kind of, maybe there's an MPLS command they're going to use here. So maybe we can just kind of look ahead and see which one they advise using. And if not, we can always go back to the MPLS commands used in option B. Looks like they just have the MPLS table commands for that listed there. So let's go to option B and see what kind of commands are used for verification of MPLS there. Maybe there's one that will be useful in this case. So it looks like show route table MPLS, same commands that are used in the other one. So I think that's going to be a winner. That's really going to help figure out the label operations. So I'll go ahead and use those. Show route MPLS. Show route table MPLS.0 detail. And that makes sense because we know we have multiple tables here. We got inet.0, we got MPLS.0, and we've got inet 6.0, but we're going to be looking at MPLS.0. Extensive. But we're only interested in the labels that are used in this trace route. So label 18 is the first label. And it looks like we've got label 18 listed twice. We've got one with a S equals 0, and then one without the S equals 0. The one with the S equals 0 has a different next hop index. It also, but it looks like it belongs on the label switch path to ASBR1. Let's take a look at the other label, and maybe that's on a different label switch path or LSP. Oh, and it looks like there's actually no information for label 23 on this router here. It doesn't have a 23, so maybe there's a label 23 on the ASBR1. And sure enough, there's a ASBR1 has label 23, but P1 only has label 18. So that's kind of interesting that it would show up listed under P1, even though it was a label that was not in the MPLS.0 table on P1. It's only on the table on ASBR1. So it's kind of an interesting caveat. I wonder if it's swapping, or so here it's just popping. So I guess I was wondering if it was listed in the swap or other way, listed some other way aside from just as its own label. That's something I can certainly still check. Pipe match 23, but sure enough, it just doesn't show up in the table at all there. It's only in the MPLS.0 table for ASBR1. All right, so let's go back to ASBR1, and we've got a better sense of how the labels work now. We can see that this isn't necessarily talking about P1. It's really more relating to what's happening on ASBR1. So let's do another trace route. It's still not making it past ASBR1. So it looks like we already verified the config on here. So let's go ahead and verify the config on ASBR2. Oh, and yep, and this is what we saw before. So it's missing family MPLS on ASBR2 here. So that makes a lot of sense that it's not going to be able to get past here because ASBR2, and we saw here, this was talking about the next router. So the next part here would be the next router in the path, which we can see if we're on P1, we're going to have P1, ASBR1, ASBR2. So it's unable to talk about the things happening on ASBR2 regarding MPLS because that was never set up on ASBR2. You can see it's missing this family MPLS statement. So let's go ahead and add that in there. Now let's go back and do another trace route. So it looks like there's similar issues. So let's keep going through the configuration and making sure everything is all set. Next is the protocols. So this is interesting that this might be actually worth a downvote because, well, actually never mind, because it's the ASBR, so you only need the interface for the core link. This is going to have a front door, just like the PEs have a front door to the CEs. So this is the separation between the two providers, because this is an inter-provider VPN. You've got two different providers, Autonomous System 100 and Autonomous System 200. So you're going to have doors between the ASBR. So you're not going to have these protocols that are meant for inter-AS communication set up on devices that are inter-AS. So protocols meant for intra-AS communication. I might have said inter before, but I meant to say intra, just internal to the specific autonomous system. Those are not going to be set up on the ports that are inter-AS. So it makes sense that it wouldn't be, that it would only be for RSVP and for OSPF. And then of course it makes sense that you would need both for MPLS. All right, so let's continue verifying and see, yep, that's right. Yeah, and it's 0012, which is the interface facing over P2, so that's the correct one to have in there. Let's check MPLS. And we've got traffic engineering. We've got the label switch path. We've got both interfaces. Let's check OSPF. Traffic engineering. Yep, that looks good. So now let's check the BGP group to PE2. And this has a dash, and it looks like this was configured with a dash. Next top self, neighbor, labeled unicast, so everything looks good here. Let's check the BGP group to ASBR1. So this is across providers. Everything looks good there. And this will be in Autonomous System 200. Checking the policy statement with a route filter. And everything looks good here. Check the next hop self policy. And everything looks good on ASBR2. So let's do another trace route. Maybe it made it another hop, but it looks like there's still an issue. Let's go back to ASBR1, just make sure MPLS is set up on all the interfaces. So yep, we've got family MPLS on everything. Check that on ASBR2. Yep, family MPLS is on them all. So how about P2? Maybe just check the configuration on all of these routers. And it, of course, could always be the case that the documentation is just saying that there's a situation that is possible that is not possible, either due to the lab gear not being the same version as is used in the documentation, or just some fundamental error in the documentation. Could be either one. But let's check R2. We're going to look at the show configuration of the information. Okay, so looks like the IP address over to ASBR2 isn't, well, actually this is going to be accurate, because the port to ASBR2 is going to be the one facing to the right. So in the topology diagram, let's verify that SO000 is facing to the right. And we can see on PE2, sure enough, SO000 is facing to the left. So we actually are going to need to switch these, because 001 faces to the left in my topology on the bottom, but 000 faces to the right on the top. But this is a good thing to demonstrate, because as I showed before how useful that display set relative command can be, I can show you that again. So now that I'm in 000 unit 0, I can do a display set relative. And here's all the configuration that I needed to be in 001. So I can just go over to 001 and do a show pipe display set relative. And here's all the information I need to be in 000. So now I can do a delete under 001. And I can go under 000, which I had printed out up here, grab it and paste it in. Now I can go over to 000. And I can go under 001, which I printed out up here, and paste it in like that. assuming I have deleted everything first, but I can always do a show pipe compare and I'll see multiple. I can do show pipe display set and I'll see, oh, sure enough, I see multiple addresses under 000. So I'm going to need to do that again, but I'm going to need to delete the existing config first. So edit interface G000.0, delete. This is the skip, the step I skipped. Now delete this in or paste it in. Top, show pipe compare. Looks good. Let's make sure there's no duplicate addresses. And there's not, so let's commit that. And now hopefully we'll get another hop on the trace route. Might take some time for it to come up. So maybe just try another trace route. But that was definitely an issue. Why don't we go ahead and verify the configuration for other, the ports on others. So on PE1, let's start with PE1 and verify the port on that. Well, it looks like now I've got a more interesting trace routes. They've got a no route to host message. Let's try that verification command from before. Okay, so things are definitely working a lot better now that we've resolved those two errors. First error, and I actually don't remember what the error was, but that's kind of the beauty of this command in Juniper, show system commit or show system rollback, compare 1-0, so we can see the first error was on this, and it was just an inconsequential error, so there was really nothing to correct on there. Now we can see there actually was an error on ASBR2, if I remember correctly. And yep, it was missing family MPLS on the interface. And then of course we were just on P2, and we remember what happened there. We had the interfaces flipped, thinking that the interface pointing to the left was the interface pointing to the right, and vice versa. So let's go back and keep going through these commands. On PE1, looks like we've got this showing up in the L3 VPN table and in the VPN to CE1 table, but that's expected. Because we've got this command here, and from the last video, if we remember, and actually it's going to be, yeah, because we've got this PE, well, we've got the routing instance. So in the last video, we did a question mark and saw the word also. Let's take a look at this command and see if that's where that showed up. So it wasn't here, so I'll just make sure to keep that in mind and chase down where that was later in the topology. But for now, let's just keep going with these commands. Show route advertising protocol, BGP 192.0.2.7 extensive. And that's interesting because I wonder what this command was. It looks like it's the same command, show route advertising protocol BGP, but now show route advertising protocol BGP, the same command, is no longer producing outputs. It's just interesting that it was before. So there's still lots of troubleshooting to do. It looks like the initial issue with the trace route is not resolved. So, and then of course the issue with the BGP neighbor is not resolved either. So let's just keep going step by step and verifying the configuration. So let's verify it on PE2. And then we'll make a point of verifying the ports. So on PE2, let's look at the interface configuration. Let's go into config mode so we don't have to write configuration each time. So now we've got a description to PE2. So let's verify that on CE2, this port SO1001 is actually pointing to PE2, or sorry, to P2, the transit router, P2. So on PE2, S001, sure enough, points to P2. And the way I've got my topology set up, all of the GE000s points this way are on the ports on this side. So yep, 000 is going to be equivalent to that port, so there's no issues there. IP address is correct. Scott family MPLS. So no issues there. Let's keep verifying. And we've got no issues here. This is the front door to CE1, where routes are entered and sent out from the L3 VPN. So of course we need the interface pointing to CE2 in there. This is PE2, so same thing for PE CE1 if that were the case. And everything looks good on here. Let's verify the next step. Sure enough, the port that is not in the routing instance is the one you want to have in RSVP, because this is going to be communicating with your P router, which is going to be on the other side of that front door to your CE. Same thing with MPLS, same thing with OSPF. Yep, so that all looks correct. Let's move on and verify the BGP group to ASBR2. We've got type internal, local address, neighbor, family, INET, labeled unicast. Okay, that looks good. So edit protocols, BGP group 2, ASBR2, neighbor 192.0.2.5, family INET. And now let's do set labeled unicast and Okay, so here's the command that I mentioned earlier where it's going to be in both the inet.0 table 3 table and another table as well. I unfortunately do not know what that other table would be at this point. I would bet that it's a BGP table, the L3 VPN.bgp.0, that sort of table. But the configuration looks good, so let's move on and verify the rest of it. Type external. Okay, everything looks good there. Yep, so unfortunately, in this case, that's kind of bad news because we still got the problems. And as I mentioned, it could very well just be that this example just doesn't work. But hopefully that's not the case. Got the members target set up correctly. So didn't have to make any changes on this one. Everything looks, oh, it looks like when I verified or whatever have you, I went ahead and created a new group. I left off the R. Just take a look at that configuration, BGP. So there it is. This is the one that's meant to be on there. All right. So this is going to require some more intense troubleshooting. So I'll start off by just seeing if I can ping all the links that are meant to be connected to one another. So I'll close this and just open up the two adjacent devices. So here's CE1 and PE1. You can see got a bit of an issue here where the wrong terminal is listed on the wrong tab, but hopefully if I just, if I just expand it, that goes away. So let's take a look at show interfaces terse pipe match GE. And we'll do the same here. So we've got .1 and .3, they're both in 24, so I don't see any issues with that. Let's see if it can ping. Oh, and we've got a no route to host, so there's already an issue there. 198.51.100.1. Oh, but of course, so hopefully to anyone watching this, they can kind of pick up on this. If not, this is really a good learning experience. I realize whoever's watching this might not have watched the hours of videos I posted before, but to anyone familiar with L3 VPNs, hopefully they would understand what's happening here. So there's no route to the host, but I did not specify where to check for that route. So by default, it's going to check the table inet0. So if I do a show route on that address, show route, Let's see here. Show route 198.51.100. You can see that, yes, it's in the routing table, but it's in a special routing table here. If I do show route table inet.0, which is the default table it checks if you don't specify a table, there's no route in there. It's not in that table because I've got that special routing instance that it belongs to. So when you add it here, you take it out of the default. It can't be in both instances at one. It can only be in one routing instance, and it's in the VPN2 CE1 routing instance and not in the inet.0 default routing instance. So if I just specify that table and do a ping there, so it's going to be the word instance, and it's going to be ping. Oops, and it's going to be, let's see here. So might be table. So ping, and here's, oh, routing instance. So requires that whole thing. It doesn't require the .inet.0, the kind of table it is. So it's a .inet.0. It's nothing fancy like a BGP or MPLS. And yep, sure enough, everything's good to go. So let's check the next one. So P1 here. We'll do a show int description. So the interface going to PE1 is 000. So show int terse pipe match GE000. We'll do the same thing here. Show int descriptions. So going to P1 is 001. Terse pipe match 001. So I don't see any immediate issues. Let's see if this can ping. So this is not in a routing instance here because I'm on P1. So a ping from here will be fine. But if I were to do it from PE1, 168.1.4, so in this case, I will not need to specify a routing instance because we can see this 001. This is going to be in that default routing table. It's not added to the routing instance. So if I do a show route, you can see, yep, in this default routing instance, I've got the subnet for this 192.168.1/24. So right here. And that's in the default routing table. So I don't need to specify a routing table because when I unspecify a routing table, I specify inet.0. All right, let's move on to the next one. We'll do a show int descriptions, and even from there, I can just narrow it down to P1, and we've got 000, of course. So show int terse pipe match. Let's check it on here. So, yep, and they're in the same subnet. So let's see if this can ping that. .5 was on the other one. All right, so that'll be enough to check. Let's go on and check the next one. So yep, everything looks good there. They're both in the /24 subnets, both valid host addresses. See if it can ping. Private class C range, part of the 192.168.0.0/16 private range in the class C range. So let's move on to the next one. And so here it is. We can see that the description for this says to P2. So let's take a moment and verify that that is actually an accurate description. So we're on ASBR2. We've got the link here, which is going to be kind of counterintuitive. It's a bit of a different, but we know just the way I set it up, it's going to be 0 here and 1 here. And sure enough, this is 1 going to P2. So that's going to be accurate. Now let's look at P2. So we've got 0. So yeah, that's going to be accurate. So let's take a look at the configuration on the documentation, and if it actually says to have 2 connected ports beyond different subnets, let's go ahead and submit a downvote for that, because that's not going to be a valid configuration no matter what other kind of configuration you add on there. You have to have 2 connecting ports in the same subnet. There's no way to get around that. So this is going to be on router ASBR2 and router P2. So let's check ASBR2 first. Get a screenshot of that. So here's router ASBR2. So we're going to be checking the link going to the router P2, which is going to be GE023. So this link here, it's going to be 4.9. So now let's check router P2. And then we're going to see in the topology here, well, which I actually took a new screenshot, so we don't got the topology anymore. But you can scroll up to it. And see that on P2, it's going to be GE-022. Scroll back down to P2. So GE022. And sure enough, we can see there's going to be an issue there. So it's not the documentation. The documentation looks fine. You can have 2 .4 addresses. You can see we've got .4.9 connecting with .4.11. So let's see what the mistake that I made is. And it looks like the mistake was not on ASBR2 because this is .4. It looks like the mistake is on P2. They're actually flipped. So I'm going to go ahead and unflip those. I wonder if that was this. Okay, so this is where I had just did that. So it actually wasn't flipped. So that makes things a lot easier because I can just roll back this configuration that had flipped them. And now I can do a show in terse at match GE dash and see that 000 is now correct. So let's go back here and do that ping again. So we're going to ping 3.7, which is good. And now we've got 4.9 on here. So let's ping 4.11 now. Okay, and 4.11 looks good to go. So ASBR2 is good. Let's verify P2. So we already verified to ASBR2. That's the 192.168.4.0/24 subnet. So now let's verify the .5/24. So we've already seen that there. So we're going to need to open up the next router, router PE2. You can see the interface going to P2 is 000. And we've got 5.12 on that and 5.10 here. And this is a /24. So let's make sure that's pingable. Sure enough, it looks good to go. So one final address to verify, and that's to the CE. And we'll verify it from the CE, so we don't need to specify the routing instance. So .6.14. This is going to be .6.13. So everything looks good. Hopefully the issue is now resolved now that the PE was flipped back. Not sure why I thought there was an issue with it being flipped, but hopefully that issue is now resolved. Let's go on PE1 and make sure it's advertising that route. Show route advertising protocol, BGP. So sure enough, it's advertising that route out the L3 VPN table. And interestingly enough, this is, okay, so here's that command here, the resolve VPN command. So you can see, yep, it's in the bgp.l3vpn.0 table as well as the table here. So let's actually do an experiment and let's take out that command and let's see if it's no longer in this table and it only shows up in this one. Okay. So show pipe display set relative. There's the command there, set resolve VPN. So let's delete it and commit. And now see if it's still in both. Might take some time for it to disappear. So we'll do a pipe refresh 1. And looks like it's still in both. So that's interesting, just something to note. This is a kind of a good example of how if you're ever curious about something and you're in a lab, do it. It's just in prod where you got to worry about things going awry. But if you're ever in the lab and you're ever curious, that's your time to dig in. So rolled back that change, it's back on there. We can see if there's any differences. I really don't see any, so it's just really not going to make a huge difference. Another thing I can do is put it side by side in Notepad++ and see if there really are any differences or not. So I will select this for compare using this plugin here. And yep, they're exactly the same. So as we saw, there's really no difference between having that knob enabled and not having it enabled, which is interesting. So let's jump over to ASBR1 and verify. So it looks like we're no longer doing any verification of the received route, only that it is advertising. And looks good to go. Let's check ASBR2. Okay, so here we are going to check the receive protocol. So catching the route, or the baseball, if you want to think about it that way, from the BGP neighbor 3.7, which undoubtedly is the neighbor to ASBR1. And they're both established, so that's good. We can do a show route. We can see the route for 3.0 is here, and that's this interface here. So from there we can do a show int descriptions pipe match on that interface. And I have the description on the physical interface, not the logical units. So I've got to remove the .0. And there's my nice fancy description. Sure enough, this is to ASBR1. So let's see that I am in fact receiving it. We verified that it is sending it. So yep, and sure enough, it is receiving it. Everything looks good. Looks like there's an entropy label capable. Next hop field matches route next hop. All right, so now let's look at throwing the baseball. And everything looks good there. There's an entropy label capable message here that is missing from here. All right, so time for PE2. All right, so it received the route. It looks like it's in two routing tables here, inet0 and inet.3. So Looks like there's some more verification commands. Let's do the next one. Everything looks good there. So let's take a look at this. Hopefully we're getting to the final few commands. Oh, and here we might have an issue because we're actually not advertising any routes through BGP to this neighbor, which is going to be the neighbor to CE2. So that's interesting, especially since we're receiving all the routes. So this 192.0.2.1 made it in, it was able to receive it, but it's not able to advertise it. Let's take a look at the configuration. Looks like the peer AS is 20. Take a look at CE2, just verify that is true. Yep, local AS is 20. See if the BGP neighbor is up. Oh, and here we go. Here's the problem, state idle. So hopefully that is pingable. No routes to host. Okay. So that's interesting that we've got a neighbor listed here where there's no IP address. Let's take a look at the running config again and just narrow it down for BGP. And sure enough, we can see here the neighbor is not specified correctly. Let's check the configuration given in the lab and see if it's worth a downvote. And looks like this is for PE2. Is there anything for CE2? Aha, so yep. Here we can see CE2 has got a group to PE2, but it's telling you to put this for the neighbor address. But if we go up to PE2, we can see that no such address exists on PE2. So this is obviously not a valid neighbor address to have for PE2 because there's no address in that subnet configured on PE2 at all. So it's got to be one of these addresses. And we can see actually on PE1, the connection to CE1, which of those addresses was used. And it's, of course, either going to be the loopback or it's going to be the directly connecting port. But let's check CE1 and see which address it's established with on PE1, and then use a similar method on PE2 and CE2. And you can see kind of what the issue was. So show configuration, pipe display set pipe match BGP. So, oh, well, it's OSPF here, but it's going to be a similar concept. Well, perhaps not, because you're not actually specifying a neighbor. But we can look at we can see where OSPF has established a neighbor. We can see it established a neighbor to this address here. And we can see that on this, it looks like it meant to use that same subnet there, but there was some issue in the documentation where, even though CE2 is attempting to establish a neighbor with here, there's an error in the documentation under option 3 for PE2, where it does not tell you to configure that address. It tells you to configure the wrong address. So PE2, we know that this family MPLS is going to be on the core facing link. So it's this link here that has the error. And the error is that this address is going to be different. So let's just take a look at that address and keep that in mind. So it's going to need to be a different address. We know that. Well, let's not jump to conclusions. Let's first go and look at CE2, and let's look at the addresses on CE2. So here's the address on CE2. So yep, it looks like this is a completely valid connection. They're both 6.0/24. So there's really no need to go ahead and use a neighbor address like this. We can just use the address here. So let's go ahead and downvote this, because this is definitely a show-stopping error. It's not just a typo or a misspelling or anything like that. It's actually telling you to form a BGP neighbor relationship to an address that is not configured on that device. So let's explain that very clearly, and hopefully they can correct it. If not, I'll have my own record and I'll be able to go back and kind of see, if I do this again, what that error was. So this is going to be in option 3. So in the CE2 configuration for option 3, there is an error in the step 4 configuration for the BGP group 2 PE2. The error, the neighbor IP given is not an IP that was configured on PE2 in the example. A correct IP that could be used to establish a BGP JNCIE, and spell check is kind of my best friend here. So a correct IP that could be used to establish a BGP adjacency, and let's go ahead and capitalize everything. You make this really nice and formal. This is going to go in all their business records. They're going to open a ticket for this. You're going to get it back in your email. So we'll make sure that it is as professional as possible. A correct IP that could be used to establish BGP adjacency between CE2 and PE2 would be, and it's going to be 192.168.6.13. So they got the 13 right, but unfortunately, it's going to take more than just that. You don't have to leave your email on there. So they're going to send that to me. I'll have that for my records, and hopefully they'll get that fixed. If not, that's okay. We'll just go and fix it ourselves here and then complete the verification. So these no longer need open. And we can just go here and use those pipe display set relative to really do a quick fix of that. So now we can do a show pipe display set relative and actually go into that neighbor, edit neighbor 8.51.100.13. Grab this configuration, go up, delete the neighbor. Now edit the neighbor that we want. Oops, and it's just going to be the subnet, no CIDR notation address required. So show pipe compare. And there's the fix. So now the BGP summary is going to show established. It might take a while, as we saw before. So pipe refresh 1. So pipe refresh is not something that's on all of the routers. I'm really hoping it'll be on the test, but can always just up arrow a bunch of times like this to do it manually. But it looks like it's up now. So it's interesting. I don't see it explicitly say state established anywhere like it usually does. So I wonder if it is established. It says that it's down. Let's take a look at maybe some more detail. Show BGP neighbor. Okay, so state is established. It's just showing up a little bit differently for some reason, but as long as the state is established, that's really all that is important at this point. So let's continue with the verification commands. And don't remember which one we left off on, but we'll go back to P2 and just do this one. Everything looks good with that one. So let's make sure it's advertising. And you can see here, so this is good now. This was having an issue before, it wasn't advertising that. But you can see here, of course, they want you to have that .6.13 used. It's not an issue in the documentation where they wanted the 198 addresses used here, because you can see here they're having the other neighbor. So it's going to form a neighborship from PE2 over to CE2 to this address on CE2. So that's where it's established. So it only makes sense that CE2 would then form its neighborship with PE2 on this same subnet here. So for external eBGP connections, definitely across the link kind of makes the most sense. IBGP, you will more often have multi-hop connections to loopback addresses. So, okay, so there's the route, just as we saw before. So hopefully a ping will work. Ping works. Let's do a show route detail. And we've got a label operation. Looks like it's in bold here. So let's see if we can see that same label operation here. And it looks like it does not show up. So maybe shows up in extensive. So looks like the configuration we've got here just is quite a bit different. Or not the configure. Oh, okay, okay. So they just have you skip back over to PE2, which makes sense because there's going to be no label operations happening on the C. So yep, now we've got a bunch of label operations. Push, 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 as they've got it there. So let's keep checking all the commands. ASBR2. And here we've got a swap, and it's going to be just for this push here. So we've got 3 pushes. It looks like the middle push is the label they're checking down here. So let's go back to PE2 and let's see what that middle label was, and then we'll check that on that one. So the middle label was 22, so let's check 22 on ASBR2. So now we've got a swap, and it's going to swap over to 21. So let's check 21 on ASBR1. Okay, so now we've got a swap over to 19. So we had a push, push, push. Then we had a swap. Now we have another swap over to 19. So let's go to PE1. And this is interesting. So it looks like it swaps it to this, but then on PE1, they have it check this here. And that's an interesting label to me because I don't see. So on PE1, use the show route table command to verify the PA receives the traffic after the label is popped by P1. Okay, so we're not checking P1, we're checking ASBR1 and PE1. So we're skipping a router, and it looks like that router is going to be responsible for popping one of these. So when we come up here and we do a push, 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 so it looks like that P1, so we've got, so when it arrives here, it looks like this middle push is what we're interested in. And then it's going to swap it, and then we're interested in that swap. But then here it goes through P2, and after it gets to P2, we're now interested in that original label that was in the push. So we're going to be interested in 17 in our case on P2. So let's see that PE1 has label 17. And sure enough, it does. And it's got label operation pop. So, yep, that's all the verification commands. I'm kind of curious why they didn't list the P routers. I mean, those seem interesting. There were a lot of differences. So, I mean, I guess I'm gonna pull those up and take a look. So we'll start with P2 and then P1. So, and then we'll kind of think about what to check based on what's on PE2. So we've got push, push, push. So on P2, it's going to send it over to, on PE2, it's going to first send it over to P2 and then ASBR2. So let's take note of these three labels, 17, 19, and 22, and let's see if there's information for any of them. Show route MPLS table MPLS.0 extensive label, and then I believe it was 17, so we don't got one for 17. How about 22? Nothing. Okay, how about 19? So we got one for 19, and it looks like there's a pop. So that makes sense that it's going to be pushed. So this route here is going to be sent through the L3 VPN through the label switch path over to ASBR2. So it's going to be sent with 3 labels on it. It's going to have 17, 22, and the top label is going to be 19. So when it makes it over to P2, it looks like when it comes in, it's just going to pop that top label of 19 off. So now it's going to arrive to ASBR2, and it's going to have 2 labels on it now. It's going to have 22, and it's going to have 17. But when it gets to ASBR2, it's going to swap 22 for label 21. So now it's going to have 17 and 21. So if we want to check the route that is now encapsulated with a label, and we can only see it as a label, it's no longer even in here as a route anymore. It was originally 192.0.2.1. I mean, it is going to be 192.0.2.1. Yeah, even on these ASPRs, it's only going to be in a routing table when it's entering or leaving the VPN. So I can even do show route 192.0.2.1. And sure enough, there's absolutely nothing in the routing table for this anymore because it's encapsulated as a label. So it's in the MPLS table. It's not in the routing table. It's no longer a route. It's a label, unless of course it's on the PEs, but then it's both a label and a route. And we know that it's, so going back and looking at the command we were looking at before, which is going to be show route. Let's see here. So it was, I don't remember what command that was. So this is, yeah, show MPLS, show route table MPLS.0 detail. I believe we did that on here. Yep, and sure enough, we've got routes on here. So Let me scroll down here. So P2, here we go. So show route 192.0.2.1 detail. Perfect. So here's what we were looking at. It's going to push 17, 22, and then 19 is the top label. When it gets to P2, it's going to pop off that top label. Then when it gets to ASBR2, it's just going to have 17, and then the middle label that was on here, which was 22, it's going to swap out 22 for 21. So if we go over to ASBR1, we're going to have to check for 21 because 22 was swapped. This no longer exists. So then it's going to swap that out for 19. So if we go to P1, we're going to see show route table MPLS.0 detail label 19. And it's going to pop. So it's going to arrive with that final label on it, which was 17. So if we go over to PE1, now we've got 17. So that's how it flows through the L3 VPN using MPLS. It arrives here. If we do a show route on that route, we can see it's in the L2 VPN table. It's assigned labels. It's assigned 3 labels, actually. So 3 labels are pushed onto it. But then when it gets to this P2, now it's no longer in the routing table. It's now it's no longer a route. It's now a label. So it's not even in the routing table at all. But if we take a look at the MPLS table where we look up labels instead of routes, sure enough, we can find it by looking at this outermost label, label 19. So top is kind of a good word there because you can tell, oh, it's not 17 that you're going to look for. It's 19. It's going to push 22 on top of 17 and the 19 on top of 22. So that 19 is the topmost label. So therefore we know on P2 to look at label 19. And we can see on P2 that we're popping that label. So if we remember back that 22 is in the middle, we know that we can check for label 22 on this device, ASBR2, and we can see that it's swapping it. So we know to check for 21 because that's what it's being swapped for. And then we see it's swapped again. So we know on P1, we know that it's now going to be 19, which we see there. And as was done on P2, we've just got a pop, no swaps, no pushes. And that gives us the original label that we started with, 17. And that's how it gets all the way from PE2 to PE1. So I'm sure this video went way longer than I intended, but lots of great content, I think. We saw the popping, swapping behavior of MPLS, of a route sent through a L3 VPN that's no longer a IP route. It became an MPLS label and no longer showed up in any of the IP tables, only in the MPLS tables in the devices where it was just transit traffic traveling through all the gear instead of entering or leaving a VPN, where it was just traveling through the VPN. We did a lot of troubleshooting, learned some good strategies for that. We kind of took it link by link, making sure everything was at the most simplest level correct. We were able to figure out through some troubleshooting problems with BGP neighbors not forming adjacencies. We're able to figure out problems with trace routes and not having labels assigned. You can see the BGP summary is now got established for everything. So That's the end of the video. Thanks for watching. Sorry it went long, but I hope you enjoyed the content.